Hi all and welcome to the Cat Quant 1000 series. Um, in this, we're going to be covering about 1000 past questions from CAT, SAT, IFT, and so on. It's going to be probably more than 1000. This is the first of the videos. We're going to be starting with percentages, arithmetic. We'll cover that and then move to algebra and then geometry and so on. So what we're going to be seeing are questions categorized chapter wise, right, rather than just be all over the place. We'll start off with about 32 odd percentages questions and then move on to interest and growth and so on and so forth. Click on the link below and log into mockat.com to get access to resources, quizzes of the day or daily POVs and the speed modules, the speed concepts, which is actually the bridge between knowing the stuff or learning the concepts pertaining to quant and actually implementing them in the questions, the answers, right? The speed concept module is something which is unique for Mockat. Make good use of that. And yeah, so let's start off. I'm a Cat Quant 99.99 percentiler, and here I'm going to show you my approach to solving these questions. See if you can adopt these. This is what is going to bring in the speed while answering the questions. A last key thing which I want to address, right, before we start with these questions, the fact that speed does not mean you quickly read and answer the questions. Speed means you patiently understand, go through the questions patiently, get a sense of what the question asks us to find, and then go in for the perfect approach, right? Somebody who's really quick in answering would be spending at least half the amount of time in reading and understanding. Once they've understood it the right way, you're going to implement it, or rather you're going to figure out the correct approach to answering the questions very quickly, and you'll be able to answer. All right, so take your time to read these questions. You can pause whenever these questions turn up, try it your way, and then see as to how I'm doing it. Yeah, so let's start off with the first question. This is from the CAT 2017 paper. CAT 2017, by the way, to just give you a sense, for those who don't know, is one of the easiest CAT quant papers we've seen in the recent past, right? So some of these which we're going to see in the CAT 2017, from the CAT 2017 year, are going to be easier questions. But yeah, nevertheless, let's start. Arun's present age in years is 40% of Barun's. In another few years, Arun's age will be half of Barun's. By what percentage will Barun's age increase during this period? I mean, read it fast, you're not going to understand much. But there are a few key things you need to make note of. Everything is given to you in relative terms, right? 40% of something, half of something, and so on. There are no absolute values over here. We need to find a certain percentage as well. So therefore, you can just start with substituting values, right? So you can form a brief, or rather a short table over here. We have two people over here, Arun and Barun, and something is given in the present ages, right? And that's the part which we can assume. Now, what is 40% as a fraction? We've seen that in the percentages lesson at mockat.com. That's 2/5, right? Should be knowing even otherwise. 40 by 100 is 2/5. Now, Arun's age is 2/5 of Barun. So let 5 be, we're going to assume a value. Let 5 years be the age of Barun. Then Arun's age over here is 2/5 of this, which is 2. Now, what's spoken about over here is in another few years, right? Few years to the present, we're going to add some x years, and Arun's age will be half of Varun's. Arun's age is half of Varun's, or Varun's is twice of Arun's, right? You can look at it whichever way. But x years after 2, x years after 5, Arun is half of Varun, or you need not have even done this. You could have said that Varun is twice of Arun, the other way around, right? So 2 times this over here. So 2 times this is 4 plus 2x equals 5 plus x, and x equals 1. That's it. X equals 1, we found that. What is the percentage by which Barun's age is increasing during this period? The increase over here is by 1 year compared to 5. 1 divided by 5. You should be able to mark 20 as a percentage. Those of you not familiar yet, you can multiply with 100% to convert it to a percentage form, and you get 20%. That's the increase. Increase of 1 year compared to 5 years. 20 is the answer. On to question 2. Ravi invests 50% of his monthly savings in fixed deposits and so on and so forth, 30% of the rest of the savings into something and something. Only one absolute value, the rest of it are in percentage terms. Right? What have we seen in the lesson once again? We can use a method called the index method. We can skip using a variable. We can go into something called an index method, which is simple. We can assume a simple value to start with, and then relate it or link it to the actual value and answer the question. What is the easiest number to work with? 100, right? Ravi invests 50% of his monthly savings. Let his monthly savings be 100, right? So savings over here, or rather, we will write it on the bottom, right? Savings, let that be 100. 50% of that, which is 50 rupees, is getting into fixed deposits, right? Fixed deposits over here. And 30% of the rest of his savings, right? 30% of the rest, the remaining is 50. 30% of the remaining 50 is coming to 15, right? So you've got to practice with these, just make use of the speed math modules, right? 30% of 50, you shouldn't be wasting time with that. I mean, cancelling the zeros and getting 15 over here, you should be quick with this, right? 30% of the rest, which is 15, is getting into stocks, right? Is invested in stocks. And the rest goes into the savings bank account. Savings bank account, right? And 50 plus 15, 65. The remaining is 35. Okay. Now, if the total amount deposited by him in the bank is rupees 59,500, if you're reading it very quick, you might miss out on whatever is inside over here in the brackets. Unlike verbal, whatever is in the brackets in quant or DILR are very, very important. Why would they give you otherwise? In verbal, it could be an author further stating something in brackets, right? Some extra information which might not be required for the solving of the passage. But when it comes to quant or DILR, every word is important, right? So the total amount deposited by him in the bank, and what is that in the bank? The savings account and the fixed deposits. The FD over here and the savings account over here, both put together, that's the bank over here. How much is that coming to? 50 plus 35, 85, right? In the index form. This is the index method, right? If 100 was the total savings, 85% of that is getting into the bank, right? If that is rupees in actual terms, right? We've seen this, it's a simple one. We've seen this in the lessons. If that is 59,500, then Ravi's monthly savings is how much? How much is this going to be? Now, these two are going to be in the same ratio. If this increases, this also increases. In school, we would have used a variable and said 85 by 100 equals 59,500 by x. There are 2-3 ways to do this. One is to simplify the ratio and find this out. We shall see that in different questions. But numbers which seem a little difficult, the usual tried tested approach. The known diagonal, right, 100 into 59,500 divided by the opposite value 85, and that's it. This is what I've told you in the lessons, right? This is what you need to follow. Even if you do it as 85 is 59,500, 100 is x, and then you divide and equate them, you're going to get x equals 100 into 59,500 divided by 85, which is the same as what we have over here. You can directly write it. Skip using a variable and all of that and just go in for this. When they are directly related, the product of the known diagonal over here divided by the opposite value 85, and that's the missing value over here, right? What is this going to be? Divide by 5 and you get a 17 and you get a 119. 17 tables, if you know speed math modules, we have that, and I've told you to do it. You would know 7 17s are 119. You get 700. 700 into 100 is 70,000, and that is the answer for this question. All right, 70000, right? That's the answer here. On to question 3. The number of girls appearing for an admission test is twice the number of boys. Relative terms, 30% of the girls and 45% of the boys, all of them are in relative terms. We need to find the percentage of candidates who do not get admission. The percentage, again in relative terms, no absolute value given to us in terms of hard numbers, right? One of the easier years, CAT 2017. Does it mean it's not important? Nope, definitely not. Every year you have easy questions. You could get easy questions like these, right? So the number of girls appearing for an admission test is twice that of boys. Now, immediately I formed a table. The reason being, you have girls and boys, and you have admission and no admission, right? And those who are not getting admission, that's it. It's a 2 cross 2 table, right? It's not going to be a Venn diagram because you can only fall under girls or boys or one of these two, admission or no admission. They're mutually exclusive. So let's assume number of girls appearing for an admission test is twice that of boys. Friendliest number over here is 100. This is 100. This is going to be 200. That makes the total 300. 30% of the girls, 30% of the girls, and 45% of the boys get admission. 30% of 200, 2 zeros are cancelled, 32s are 60. 45% of the boys, so that's simple, 45 itself. These 105 people get admission. What percentage of the candidates do not get admission, right? Who do not get admission is percentage of total. Out of 300, how many do not get admission, no admission? The difference between these two, that comes to 195. That's it. That's the question. To convert it to a percentage, you multiply with 100%, and 195 by 3 is nothing but 65. 65 is the answer for this question. Out of the shirts produced in a factory, 15% are defective, while 20% of the rest are sold in the domestic market. If the remaining 8840, only one absolute value, the rest are in percentage terms. Done. Once again, start with the index method in this case. We assume a value for the index, right? And then work with it. Total shirts, let the total shirts produced be 100. Out of this 100, how many are defective? Defective equals 15%, okay? 20% of the rest, right? 20% of the rest, remaining is 85. 20% is 1/5 of 85, 17. If you can do that quickly and directly, well and good. If not, 20%, 1/5 of the remaining, after removing 15, the remaining is 85. Multiply, if you know the tables or even otherwise, you're going to get 17. 17 are those sold in the domestic market, right? Once you're done with these, the remaining 8840 are left for export. Now, what's the export of 100? 15 plus 17, 32 are done, defective and domestic. The remaining 68 are for exports. In actual numbers, we are told that 8840, right? 8840 are those in actual terms. Then the number of shirts produced in the factory, total shirts produced over here, 100 is going to be what? Right? Cross multiply, divide by the opposite value. You can do that. Let me teach you another one, right? Where let's simplify this. Divide by 4, you get 17. Divide by 4, and you're going to get 2210. Dividing by 17, what are you going to get? 117s are 17, then 51, 317s are 51, and 0. So the ratio over here, exports, is 1:130, meaning if 1 in the index corresponds to 130 in actual terms, then 100 over here corresponds to 130 followed by 2 zeros, 100 times that. 1:130 is the ratio. If one part is 100, then 130 is going to be 13,000, and option 2 becomes the answer here. No variables, a quick and simple approach. In a village, the production of food grains increased by 40%, and the per capita production of food grains increased by 27% during a certain period. Again, percentages, but hold on, something slightly different over here. Production of food grains, how much we produce. Per capita production. Per capita is production by population, okay. The percentage by which the population of the village increased, okay. So we have a formula over here. So per capita is nothing but the population divided by, the production divided by the population per capita, per person, right? Production by population, that's the base formula. Now what we are told over here is the production of food grains has increased by 40%. The production has gone up by 40%, 1.4 into production divided by, what's the population? We don't know the percentage by which the population grew. We need to find that out, all right? What did it grow by? 1 plus x, right? 1 plus x percent types, x by 100 if you want to write and be precise. But a lot of times what I advocate is just use a variable x or y and understand it's the multiplication factor, all right? So y is nothing but 1 plus x by 100, right? That's the multiplication factor. By x percent, if the population grew, then y is 1 plus x by 100 into the population. I can, just for convenience sake, just write it as y, right? Over time, you don't even need to write this. You'll understand there's a multiplication factor. If you find this to be something like 1.4 or 1.2, let's say, then you know it's a 20% growth. 1 we need to remove, and 0.2 into 100%, right? Percentage is lesson, just go through that in case you're not too familiar with this. Now, 27% over here is a growth in the per capita, right? So 1.27 into per capita growth. How do we solve for y? We seem to have 4 variables over here, but actually these 3 variables are linked. Per capita equals production by population. Production by population is nothing but per capita, right? I can cancel it on both sides, and we get y equals 140 by 127. Get rid of the decimals and move it below, which is nothing but 113 by 127, right? Y over here is 113 by 127, which is nothing but 1 plus 13 by 127 equals 1 plus x by 100. Right? But just looking at this, you should know 13 by 127 is closest to 10% in market and go, right? That comes with practice and experience. Now, in case you're not too familiar, you can always use the calculator, right? Or you can just observe in simple terms. 13 by 127, x by 100, sorry, over here, right? X is 1300 by 127. That's a painful root. Just quickly think about it. What is 10% of 127, that's 12.7. It's very close to this 13 which we have over here, right? This 13 extra. What about 13% of 127? 13% of 127 is nothing but what I need to do over here is I need to add 3 times 1.27. 10% is 12.7. 3 times 1.27 or 3 times 1.3 comes to about 3.9, and the number is shooting up to around 16.6 or something like that. It's much bigger than my 13. The closest over here is 10%. Or even better, just use the calculator, right? 13 by 127 into 100%. It's the CAT exam, and you have the calculator nowadays. So option 3, 10 is the answer for this question. In an examination, the maximum possible score is n, while the pass mark is 45% of n. A candidate obtains 36 marks but falls short of the pass mark by 68%. Okay. Which one of the following is then correct? Okay. So what do we have over here? So we have the maximum possible score, which is n. Fine. The pass mark over here is set as 45% of n. And this candidate over here is falling short of this by 68%. So the candidate's mark over here is nothing but if you're less by 68% from this, if you're below this by minus 68% of this, then 1 minus 68% is nothing but 0.32, right? 0.32 into pass mark over here, 0.45 into n equals 36. A one-line equation we get over here. Let me finish this and then we look at this once again. It's nothing but 32 by 100, all right? And 0.45 is nothing but 9 by 20, right, into n equals 36. You can get rid of 9 over there, a 4, and we get an 8. 8 we divide with a 4 over here, and we get a 5, and 2 over here, and you get a 50, and you get n equals 50 into 5, 250. So what's in the range over here? 250. That's going to be option 1. N is between 243 and 252. Now, what did I do over here? Quick look once again. The maximum possible score is n, right? Which is what we have to find. The pass mark is 45% of n. Just wrote it down. And then somebody gets 36 marks, which is 68% less than it. If you're 68% less, the multiplication factor is 1 minus 0.68, which is 0.32. 0.32 of what? 0.32 of the pass mark, which is 0.45 into n. And that is given to me as 36. That's the equation. Solve for it and you're done. Some of you might ask me, hey, why not use the index method? Only one absolute value given. You got to be flexible, right? Write down, see where it's heading, and accordingly make amends. Can you use the index method here? Yes, you can, but is it going to be as quick? Probably not, right? Questions like these, where one simple variable is given and they're all linked up in percentage terms, one below the other, just form the equation and get done with it. The income of Amala is 20% more than that of Bimala and 20% less than that of Kamala, right? When this link is given to us, the first step I would do is A, B, and K and start writing them in percentage terms. 20% is nothing but 1/5. If A is 1/5 more than B, 1/5 more than B, if B is 5 parts, A is going to be 1/5 more, becomes 6 parts. A is also 20% less. 20% is 1/5, 1/5 less than K. 1/5 less than K. If K is 5 parts, 1/5 less than that is going to be 4 parts, right? That's it. These are the ratios. And I have to merge the ratios, and we know that pretty well, right? How do we do that? This is the connecting term, right? Because it's part of both the ratios. I need to bring it to the same value. It's the LCM of 6 and 4, that's 12. I multiply this with 2. I multiply this ratio with 3. 2 6 are 12. 12 is 2. If this is 12, this becomes 2 5s are 10, right? 6 is to 5 holds good. 3 into 4 is 12. And if this is 12, this becomes 3 into 5, which is 15. That's it. We've linked up the ratios. Now, if Kamala's income goes down by 4%, right, here's where you've got to be flexible. 4% of 15 gets into decimals. So we can always add zeros. How many zeros do we want? If the income of Amala over here is 1,200, then B is going to be 1,000 and K is going to be 1,500. Now, 1,500 is going down by 4%. So 4% of this, 100 is knocked off, 4 into 15 is 60. And B over here goes up by 10%. That's the easy part, plus 100. Then the percentage by which K's income would exceed B. K's income, which is 1,440, is going to exceed 1,100 by how much? By 340. right? Excess of 340 divided by who? We are comparing it with exceeds Bimalas, right? B's. 340 by 1100 into 100%. That's it. Get rid of the two zeros. 340 by 11. 3 11s are 33. Then a 0 and then a 10 by 11%. 30, 10 by 11. The closest here is option 3. 31 is the answer here. Meena scores 40% in an examination after review. Even though her score is increased by 50%, she fails by 35 marks. Okay. She scores 40% and her score is increased by 50%. So it becomes how much? 60%. My score is increased by 50%. Half the marks I'm given extra 20%, and it comes to 60%. A percentage on this percent, I have to apply 50% and increase it. 50% or 40% is 20%, and you increase by 20%, you get to 60%. When you're at 60%, or rather Meena's 60%, she fails by 35 marks. So there's a pass mark over here, and she's failed. She's less than that by 35 marks in absolute terms. If her post-review score, this was after the review, if this post-review score is increased by 20%, this is increased by another 20%. 20% nothing but 20% over here is 1/5. 1/5 of 60 is 12%. If I increase this by 12%, I bring it to 72%. Then what's happening? She will have 7 marks more than passing score. This is going to be 7 marks, right? 72% is 7 more. Okay. The percentage score needed for passing the exam. I need to find out the percentage over here. What's the percent? A lot of you at this stage, you'll know that 12% is the difference. You can split in the ratio of 1:5, and that comes to 2 and 10. Reduce this by 2 and you get 70% straight up. You can even mentally do this, right? Otherwise, if you want to look to adopt this or see what the steps are, it's quite simple. 7 plus 35, right? These 42 marks over here, 42 marks. The difference between 72 and 60% is what? 7 marks below to get to the pass mark and 35 more to get to 60% from 72. So 7 plus 35, the total of 42 marks is nothing but how much percentage? 72 minus 60%, which comes to 12% of the total, right? Then what is 7 marks going to be? Divide this by 6 and we get 7 marks is nothing but 2%. 7 marks less to bring it to the pass mark is nothing but 2% less. You reduce this by 2% from 72 and you get to the pass of 70%, and that's it. That would be one of the quickest ways of solving this question.